Hello, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abuzena. That channel is specially created for you and I to come together to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. I wish to thank and acknowledge you for staying true to us and by subscribing. Thanks and God bless. Today's class promises to be as interesting, as educative, and most importantly, as fun as possible. In the last videos, we looked at the topic partial fraction, which seems to be a very simple topic to us now, because we had 3 lessons on it. I did say from the beginning that partial fraction, in summary, is the reverse process of getting the components of a fraction that were either added or subtracted to generate a rational algebraic fraction. So, in this case, all we need to do is to break down the rational function into the constituent part of it. And for the first case, we looked at when you have a distinct factors as denominators, whereby we use the cover-up method. In the second case, we have repeated factors as denominators. And in that case, we use the method of comparing coefficients. And similarly, in the third case, we have the case of non-factorizable denominators, where once again, we adopted the approach of comparing coefficients. Today's lesson, which promises to be fun, as I said earlier on, is looking at a rather unique case of partial fraction, whereby the numerator is either of equal or greater degree than the denominator. If you are very observant, in the first 3 cases, the numerator always comes with a lesser degree than the denominator. But for today's lesson, which is a bit different and very unique indeed, we are going to have cases of having either equal numerator, equal degree as the numerator, or greater degree than the denominator. And the approach to adopt here is that we use the concept of long division of polynomials to break down the algebraic rational function before approaching it as a partial fraction problem. Exactly. So, without wasting much time, let's look at the board. The question we have here is x squared plus 2x minus 4 divided by x squared minus 2x minus 3. We have to resolve that into partial fraction. As I said, we have to first break this down using polynomial. We have x squared plus 2x minus 4 to be divided by x squared minus 2x minus 3. Here, the value outside is the divisor. So we go by having x squared in x squared, 1. So 1 times x squared, 1 times minus 2x, 1 times minus 3, minus 3. And then we subtract this polynomial. So we have 2x minus x, 4x there, minus 4 minus 3, minus 1. So tentatively we are saying that x squared plus 2x minus 4 over x squared minus 2x minus 3 is equals to the quotient, that's what whole number, plus the remainder, 4x minus 1 over the divisor, x squared minus 2x minus 3. So we have been able to resolve this as the first step into this part. If you look at the right hand side of the plus sign, you can see that this is proper partial fraction candidate, because the numerator is degree 1, the denominator degree 2, which is order. So it is this circled part exactly that we now resolve. So technically speaking, it's as though they have to resolve just this into partial fraction. So we have 4x minus 1 over, now this x squared minus 2x minus 3 denominator is going to be factorized into x plus 1 x minus 3. These are the factors of x squared minus 2x minus 3 proper. And this takes us back to exactly case 1 where we have distinct roots. So then we simply say this equals a over x plus 1 plus b over x minus 3. And that gives us a x minus 3 plus b x plus 1. I'm taking it for granted that we have done this in case 1. So if you have issues with anything I'm doing here, I simply encourage you to go back to our video on partial fraction, the very first video, where we have distinct factors as denominators. So at this point now, we can now set x to be 3. In order to eradicate a, we set x to be 3. That means 4 times 3 minus 1 equals to 3 minus 3 is 0 times 8 is 0. Then here b, 3 plus 1. So 4 times 3 is 12 minus 1, 11. 3 plus 1 is 4, 4b. Therefore, b is 11 over 4. That's for b. In a similar vein, to eradicate b, we set x to be additive inverse, which is minus 1. X will be minus 1. Hence, we go all over 4 times minus 1 equals to a minus 1 minus 3. So we have minus 4 minus 1. That's minus 5. The minus 3 minus 1 is minus 4a. This leaves us with a as 5 over 4 plus 5 over 4. Because minus 4 minus 1 is minus 5. And minus 1 minus 3 is minus 4. So a is 5 over 4. So essentially, all we need to do now is to just slot in into this expression here, that we have then 1 plus the entire partial fraction here, a is what? 5 over 4 over x plus 1. Then plus b is 11 over 4 over x minus 3. Hence, in conclusion, you can see we have 1 plus 5 over 4 x plus 1 plus 11 over 4 x minus 3. And that is the solution to the problem on how to resolve a partial fraction in which the numerator is of higher degree than the denominator, or equal degree of the denominator. And with that, we come to the end of the class today, which I believe you found interesting. If you do as I did, please don't forget to subscribe, like, share, and ultimately put on your bell so that you'll be first to know when the next video is dropped. Thanks and stay blessed.